So welcome everybody again. Welcome from Trade Consultants and also from Carbon Mines at this webinar about the new data we have available for SimaPro users, the Carbon Mines cm.chemicals database. We started a little bit later to allow more people to join. Before we start, this session is recorded and the recording will be made available in a few days on the SimaPro Help Center. So if you have to leave, you can still watch the entire webinar later on. During the session, you can ask questions. You see a question box on your screen. Please, ask your questions there, concise as possible. We will try to address them either during the webinar or afterwards in the Q&A. And there are always a lot of questions we found, so we cannot answer everyone, but we will try to answer you after the meeting via email. May not be right away, please allow some time, but we do our best to answer all the questions. Again, thank you for joining us. With me is Arne Ketelhoorn. He's the Managing Director at Carbon Mines. Also joining Raoul Meijs, also Managing Director at Carbon Mines. And my name is Michiel Oele. I'm the SimaPro Product Specialist. Dr. Arne Ketelhoorn has extensive expertise, not expensive, I hope, in life cycle assessment in the chemical industry, which he obtained during his work at Carbon Mines and also during his previous position as team leader of a life cycle assessment team at Aker University. And his previous experience as an environmental consultant working on the clean development mechanism in Beijing means he contributes knowledge in the field of environmental assessment and business administration. So welcome, Arne. And Raoul has gained profound experience in chemical engineering, process design, and life cycle assessment during his work also at Carbon Mines, and also as leader of a life cycle assessment team at the Institute of Technical Thermodynamics, also at Aker University. There he focused on the life cycle assessment of renewable carbon feedstock for petrochemical products. That includes polymers, chemicals, and fuels. And Raoul holds a diploma from University of Bochum in Germany. And he's leading the technical product development at Carbon Mines. And for myself, I'm the SimaPro Product Specialist. I play a role in the product development of the SimaPro desktop version. I also give technical support to our users, so I may have spoken or emailed with many of you. I'm also part of the database team at PRE. The database team is responsible for implementing and updating data libraries and impact assessment methods. One of them being this Carbon Mines database, but other examples are EcoEvent and, well, so many other examples. And I'm a chemist too. I'm an environmental chemist from the University of Amsterdam, and I'm really happy to see this chemical database coming available in SimaPro. Sorry. What we will cover today, Arne will tell more about the highlights of the cm.chemicals database, overview of the contents and the coverage, the data sources and the methodology. Later on, I will tell a little bit how to acquire the data and give a little tour in SimaPro, how it looks like. And we will have a Q&A session when there's time left to answer any questions. A little bit about PRE Consultants. PRE Consultants started in 1990. We developed them the very first version of SimaPro, with the goal, the aim of making sustainability more fact-based. At that time, environment was an issue, but people said, oh, PVC is bad and wood is good and anything else, but it was not really fact-based. And the founder of the company, Mark Goedkoop, said, LCA is the way forward. I'm very proud to have joined this company in '95, and I think it's still very valid aim to make sustainability fact-based, and indeed it's a driving value for all the people working at PRE Consultants. About SimaPro, some statistics, and we are really proud of after.
May I interrupt you for a second? There's a question in the chat that we cannot see your screen, which is something I can confirm.
You cannot. Oh, sorry. This is better.
That's perfect. Yeah, thank you.
Okay. So, oh, I'm so sorry for that. Anyway, we have some statistics we are proud of about SimaPro. We have, and Prey Consultants, obviously. We have 10,000 users of SimaPro worldwide. They are based in 80 countries, and yeah, we have 24 partners that support these users all over the world. We have 31 years of experience in November, so yeah, we're really proud of what we have achieved so far. There's a lot of things I can tell, but this meeting is about this chemical database from Carbon Mine, so I will not continue with any more of this stuff. And we want to start with a little poll. And that's actually, when you think of chemical LCI data, what do you value most? We want to know if you prefer wide geographical coverage, wide chemical coverage, because you look for data you're not able to find in other databases, if you look for the most recent data, or if you look for transparency in the model and accompanying documentation. Some cards start the poll. The poll is now open, and yeah, I hope you can pick one answer which is relevant for you. Yeah, see the first answers coming in. Well, that's going fast. 2/3 has voted by now, so I'll give it a few more seconds, and we'll see. So your last chance to vote. 81% has voted by now. So it's 3, 2, 1, and I close the poll. And I'm going to share the results. I hope. 49% has chosen wide chemical coverage, not present in other databases. 34% has chosen transparency. 10% is choosing recent data, and 7% is choosing wide geographical coverage. That's very interesting for us to know. And well, thank you for voting. I am now going to hand over the screen to Arne Kool. He will explain more about the chemicals database. And see. Make you the presenter.
Great, thanks so much.
Yeah.
Let me quickly start sharing. Okay, Michiel, can you quickly tell me if you can see my screen now?
Indeed, I can see your screen. So you're better prepared than I am. Sorry.
Okay. I'm also turning on my webcam. So hi everyone. Maybe you can also see me now. First of all, thanks so much, Michiel, for this great introduction, and thank you everyone out there for joining this webinar. I think we started developing this LCI database for chemicals and plastics, let's say 5, 6, 7 years ago. So it's kind of quite some time. So you can imagine it's quite a big thing for us to have this launch now and to have all of you here. So thanks a lot for coming. Before we're gonna start going into the details for cm.chemicals, our new LCI database, just a few words on us. Who are we? And we are Carbon Minds. We are the people behind the cm.chemicals database. We are a data analytics company and lifecycle data provider based in Cologne in Germany. And everything that we do is basically based around environmental lifecycle data for chemicals and plastics. So we provide our cm.chemicals database so that you can use it, for example, in SimaPro. We also use our database to provide analysis. For example, we provide benchmarking of different suppliers for the same chemicals, and we do a more general consulting and LCA training. And even so, we are a young company. We're lucky enough to work with some of the largest and most advanced companies in this world in order to improve the environmental performance. Carbon Minds is a spin-off of RWTH Aachen University. So we have a strong academic background. Raul and I, co-founders, we have previously been team leaders at the Aachen University, and this is also the time where a lot of these emerged. And we did this together with Sang-Won Soo, professor at the University of California in Santa Barbara, and Andre Badu from ETH Zurich. But much more important are not the people who started the entire thing. Those are the people who keep everything running. And we are super happy to have assembled an amazing team of chemical engineers, of sustainability enthusiasts, which are the faces behind everything that we are doing. And what we're going to talk about today is the cm.chemicals database. And I just want to start with a just very quick facts, rough overview. It's a lifecycle inventory, a full lifecycle inventory database for chemicals and plastics. It's huge. It has more than 45,000 data sets, and it covers more than 1,000 chemicals and plastics. At the same time, it's very regionalized. We basically consistently cover all the production regions with more than 190 countries. And it's certified and third-party checked by TÜV Rheinland, the methodology, but also the data quality. So you don't have to believe us saying that the quality is good. So we let it regularly be independently checked by TÜV Rheinland. And in this quick presentation, I would like to show you, on the one hand, how did we build it? I saw you're interested in transparency and the methodology, so let's talk about methodology. And afterwards, let's talk about coverage. What kind of data sets can you find in there? How did we build this database? So you won't be surprised to hear that, that building a database typically starts with collecting a lot of data. So what is the input data that we needed and that we use? On the one hand, it's data on the locations where chemicals and plastics are produced today. Because a production location is just very important. It determines the regionally specific supply chains for products, for energy. Yeah, and these can have very different emissions intensities. For every single technology that is used along the supply chain, you might know that chemicals can be often produced with 10, 20 different technologies, exactly the same chemical. We need very detailed technical models. We need some mass balances. We need energy balances, direct emissions. So we collected a lot of techno-economic assessments for all the different production technologies from the different licensors of these technologies. And the third thing, which is really important when you want to understand the environmental impacts of chemicals, is trade. Because I'm going to show you later that emission intensity is just very different in the different countries in the world. So it's almost not comparable. But when we consume a specific chemical, let's say in the Netherlands, it doesn't mean that it has been produced there. There's a huge harbor, Rotterdam. It might have come from basically all over the world. So we need to understand these trade flows. And this is data that we collected for more than 5 years now, and we put it together into our modeling approach, which we believe is quite unique. What is special about this modeling approach is that we don't start, like many other databases, on the country average data. So starting with technology by country data sets. No, we start at a much higher level of granularity and explicitly model every single plant in the world for the large volume chemicals, together with their plant capacity, their production volumes, the detailed technical model of the technology used from the specific licensor of this technology. By knowing where the plants are located, we can understand how they are clustered in integrated production sites. Because chemical plants, you never find them just on a green field. They are clustered in integrated production sites, and we use this to improve energy efficiency, to use co-products from other plants, so basically reduce transportation distances. And using this modeling approach, we can now understand inside the production site, what are the production mixes, what are the technology used to produce the intermediates, the chemical intermediates, and by this means we understand the consumption mixes of the different plants. So if you take a polypropylene plant, which uses propylene, it will get the propylene most likely from the plant that is located right next to it, and this plant can use a different technology, like the average technology on the market. And this is, I think, the strength of this import. But of course, not everything comes from inside the production site. The rest comes from the national market. Using this modeling approach, we've now modeled more than 2,000 individual production sites. The output of these production sites per chemical, they form the national production mixes. Parts of this production mix are also consumed in the same country, but some other parts will also be exported to other countries, and equally our consumption mix in a country, it will include imports from many different other countries. So only once we've modeled the chemical industry really in every single country, we could close this model, close the trade flows, and calculate our results. And we're going to look into these results just in a second. But before we do this, just a quick overview of what we did. And this is what I forgot here. Of course, we know who owns the plant, and we can show basically benchmark the supplies on this. It's not part of the data set, but this is also something that we do more in the consulting field. But how do we do it? How do we maintain it? This is just a quick summary. We have our input data from different places, and we use this input data to build our life cycle inventory model. And we have just showed you the structure of this life cycle inventory model. And using this life cycle inventory model, we export systems processes, so basically cradle to gate life cycle inventory, which are then available in the cm.chemicals database. And we don't do this once and let it there forever. No, we annually update not only energy mixes, but all the different plant capacities along the supply chain. And every year this will again be checked by TÜV Rheinland and certified, so that you can be sure about the data quality. So cm.chemicals, what type of data sets are available? In short, you saw them on the slide before. Those are technology data sets, they are production mixes, and they are consumption mixes. Let's have a closer look at them and start with technology data set. The definition of a technology data set would be a life cycle inventory data set, which you can use to calculate the environmental impacts and the different impact categories for an average unit produced with a specific production technology. This could be in a country, in a region. I brought an example here, which I will use throughout this presentation. It's a methanol production, and globally it's today mainly used, produced based on four different production routes. There are new bio-based routes, but the fossil ones are steam methane reforming, gasification of coal, coke oven gas utilization, gasification of heavy fuel oil. And what you see here are the global shares with which these are used over the world. They are very different on a national level. For example, gasification of heavy fuel oil is mainly used in Germany, and there's, I think, one single plant in Russia. Gasification of coal is mainly used in China, and the same goes for coke oven gas. Yeah, so this is just a global shares. And technology data sets, they don't look at the mix, they look at every single technology individually. And this is important because these technologies are just very different. So I brought the example of the two mainly used technologies, gasification of coal and steam methane reforming of natural gas. And those are the flow sheets. You can see they just work differently. They use different feedstocks. On the very left side, coal and oxygen versus natural gas. They have different production steps in between. So this results in different energy demands, different waste. And finally, they have completely different environmental impacts. I brought an example why technologies are important, and I brought the example of the climate change impact, the global average for these two technologies. And you can see that the impact of coal gasification is very substantially higher compared to steam methane reforming. And these absolute values, they are global average now. They differ in all the different regions. So, for example, the way the coal is sourced, where the natural gas comes from. So the values they change depending on what region you're in. And maybe a small disclaimer here. I use the example of carbon footprints of methanol, not because I like methanol better than other chemicals or climate change better than other impact categories. Of course, all environmental impact categories are super important and supported by this database. It's just an example here. And those are the data sets. Yeah.
I have a question from Rodrigo Alvarenga. I hope I pronounced your name right. It's actually a question how you actually got the data for all these technologies and data sites and that sort of things. I mean, it's hardly and just believable that you collected data for all this. And we have come to this in a moment. And the other question is related. I mean, Charlotte Valliere is asking, can we see where or which suppliers the data are coming from, or which sites, or which technologies?
Yeah. So let's start with the first one. It might be even more unbelievable when I tell you that we specifically modeled 18,000 plants, and I get this reaction a lot. But we use several large-scale data sources, and one is market intelligence data, which is basically the information where are plants at the world, what company runs these plants, from whom do they license the technology, so basically what process type is, and what are the plant capacities and capacity utilization factors. So basically who produces how in the world. If you now combine this with the second type of data that I mentioned, the techno-economic assessments, which you can get from different sources, and there are also 4 or 5 very trusted databases for the chemical industry and even more, then you get these technical views. And this is nothing new in the LCA world. So this data has been built for decades. By other providers, simply to calculate the costs of your competitors or of your suppliers. It's completely new that we use this type of data also for LCA, but this is why this comprehensive data is out there.
Okay.
I hope this answers the question. The data sources, for this, I would like to refer you to our methodology, where we basically have a description, like more detailed description of the data sources. There are many sources in there, so we can't give out all the different names, but there are in the description what type of data sources it is, and data quality ratings, which are again certified by the TÜV Rheinland, so it's not our own perception. It's basically the data quality.
Thank you.
Yeah, thanks a lot for this question, and please feel free to ask more when these questions come. In the meantime, I will continue with the next type of data sets that is inside this data set. But before, just a quick summary. I think what is special about this data set is that we really cover for these large volume chemicals, particularly all the industrialized technologies. So for propylene production, for example, those are about 20 different technologies that are used. Yeah? So it's very technology specific, and those technologies in the end form the production mix. And this is what we are going to talk about next. So what is a production mix? A production mix, the definition is basically an FTI data set that allows you to calculate the environmental impact of an average product unit produced in a country or in a region. So if you don't know how your input in your LCA study is produced, what technology is used, you just know that it's a producer from China, let's say. This is a moment when you would look into the Chinese production mix. And we have quite a lot of production mixes. This is again for the methanol examples, all the countries that produce methanol in the world. And you can see that the environmental impacts differ quite a lot among the different regions. So sometimes when I talk to LCA practitioners, they tell me, well, can you just give me the average for this chemical? Maybe the global average data. But I like to point a lot towards this regionality because I believe it's very important. I brought this example here. Assume we just took the global average of methanol production in the world. This would be a carbon footprint of 2.1. Then people sometimes say, well, let's not take the global average. Let's get a bit more specific. Let's take the European data set or the Chinese or the the Asian or the North American one. Let's see what happens then. And to the example of Asia, this would give us 2.8 kilogram of CO2 equivalent per kilogram of methanol. But I think what we need to keep in mind is that this is not representative of the countries in this region. So as an example, if in reality, you know, your product comes from India, the Indian production mix is much, much lower, 0.7 kilogram of CO2 equivalent per kilogram of product. So when LCA practitioners fight about details in energy demands, if you take a regional data set, and in this case want to refer to an individual country, you get a factor 4, not of variance, but really of error in your study. And this is why we believe that this regionalization is super important, and maybe particularly important for the chemical industry, where we have large differences in technology. And I think this question also leads us to our next poll. And Michiel, you've already prepared this poll. Would you like to open it in the background? I'm gonna try to find it on my other screen. I think a new poll is open. What we wanted to ask you is, for what regions do you typically need LCA data? So what regions are important for you? And I see a lot of people are already voting.
Meanwhile, I have another question for you.
Yeah, please.
So this is from Michael Berkay. He asked about, he says, I understand the methodology for basic chemicals, but what happens if you have more complex materials like polyurethanes or styrene acrylates? How do you actually determine where all these basic chemicals come from? Is that market information, or that's my thoughts?
I mean, the chemicals that you mentioned, they're like polyurethane, they are still very large volume chemicals. So we can still get this as an extremely high quality level. This is basically the approach that we showed you. But there are also other materials. For example, we have modeled hundreds of additives. Or like more specialty chemicals, and here you really don't know who produces them, where in the world, but you know the technology. So in this case, when we don't have the market information but just the technology, we provide this technology data set for the specific chemical, and this then has a different quality indicator, but the chemical is there then. So in this case, short answer, technology data sets.
I think we can close the poll. 87% of the people voted. Let's see and share the results. So it's a little bit as I expected. Asia is number 1.
Okay, can you read them out? I think they are not fully shown on my presentation.
Okay, it's Africa 5%, 52% Asia, 5% Australia, 83% Europe. That's not surprising because I think most of the LCA practitioners are based in Europe. 39% North America.
Oh, okay, perfect. Thanks. Then I see them. I was not aware that you could choose 2 regions as one person, which of course makes a lot of sense. So,
yeah.
Okay, great. Yeah, thanks a lot. Yeah, and so what we can see is we have a huge spread. And when you look into this map, there are several people looking into North and South America. And here you're more on the lower end of the carbon footprint, so the lighter colors. There are many other people who are looking into Asian data, and in Asia, China is the largest chemical production region. So there you're completely on the higher end. So if you're looking for data for these regions, please don't go for the global average. It makes a difference if you have a 0.7 or a 3 as your carbon footprint, and this can also qualitatively change the results of your studies. And I think the advantage is that these regions are really covered. So there are more than 190 production regions, and this is a real regionalization where we not just exchange energy mixes, but really the plant capacities along the way. And these are the production mixes in the different countries. There was one type of data set left, and those were consumption mixes. So what is this? It's data sets with which you calculate the environmental impact of an average product unit consumed in a specific country or region. So it sounds very similar, but it's a little bit different. And the difference is that here you have the local production from this region plus imports from other regions. And I tried to do a small animation here. Let me see if it works. If it works, you see some regions blinking now. And those regions who faded off, this was a production mix that you saw before. There are just many fewer regions who have a production mix, simply because the other regions, they don't produce this chemical, they just import it. Or in other words, the countries that came here in addition to the producing countries are countries that only import from other countries. But this is important. To show you this, I took an example and just zoom in a little bit into Germany, really just as an example. And in Germany, we have a bit more than 50% of the methanol that is consumed in Germany is really produced in Germany, while the entire rest comes from different countries. We have a big other slot, so I think in total it were around 20, 30 countries from which Germany imports methanol. And of course, they can have very different emission intensity. The biggest exporting country to Germany, so the big most important import country partner was the Netherlands here. And maybe on a side note, this is also related to the big harbor, so it doesn't mean that it's not produced. In the case of methanol, it typically isn't. It came in via Rotterdam to Germany, so it's a trading through this country. Is this important? We have the consumption mix. In this example, 1.5 kilogram of CO2 equivalent per kilogram of methanol. The production mix here is much higher. And why is it higher? Well, Germany uses different technologies, and you might remember in the beginning when we talked about the technology, oil gasification is used really a lot in Germany, and this is why the average footprint is higher compared to the countries from which we import. And this is why trade is so important. And I think here benefit is that this trade is covered fully on bilateral per chemical trade data. And I think these are main differentiators of the chemical database. And the other one, big one, is just quality assurance. Databases are big. You won't be able to check everything. So it's important that we don't have just self-declared awesomeness for this database. No, that we have like a real certification. And this is what we did with TÜV Rheinland. And of course, we developed this a lot at university. There's also a peer review process. We use this data for scientific publication. For example, last week, we were lucky enough to have a publication in Science on net zero greenhouse gas emissions, plastics, by a circular economy, or previously in PNAS. So there is also some peer review that happened in the building of the methodologies and this database.
I have
Okay.
a few other questions.
Yeah.
The number of questions about the differences of your data compared to, for example, the data for chemicals and plastics in EcoInvent, or those from Plastics Europe, or other chemical associations.
Yeah. I mean, if you look into Plastic Europe's, and then it's European average data. And I think a huge difference is that we can look into the countries. And if you take for electrochemical processes, for example, in Germany we have a lot of coal electricity, in France a lot of nuclear power. The impacts are just very different in the different countries. And maybe the amounts, or Plastic Europe is a lot large volume chemicals, even though it's amazing data. We just have more chemicals, about 1,000 chemicals covered.
Have you compared the results? I mean, are your results comparable with those of Plastics Europe or EcoInvent?
Yeah,
or
sorry.
Sorry?
Yeah, we constantly do this, and we also do this systematically. When do we see results? Sometimes I think EcoInvent and also Carbon Mines, we're both very transparent in the data quality indicators. Sometimes, so first of all, we should compare data sets with the same quality. Sometimes you get differences depending on the allocation approach. This can happen, and sometimes you can see differences. And when we did this, we systematically looked it up and either corrected it because we saw there was need to change something, or we can explain it, I would say.
Some more questions. One person is asking, is emission from transport included when you talk about consumption mixes? And related to that, what kind of background data do you use to model those transport emission, electricity production, that sort of things?
Yeah. So first of all, transport emissions, with this trade model, we have a lot of trade, inland trade, based on trucks, where we used basically an API, so an automatic request for road routing, that we get the transportation differences. For ships, we did something similar. We use data from a company that uses satellite tracking of ships, and it's funny when you see that, you can see it's almost like highways over the ocean, and with this we can also calculate the transportation distances. An important thing is the background data that we use for electricity and transportation and some other processes is from EcoInvent. So if you're an EcoInvent user, we believe that our database is complementary for this, and it works well together. So what we're trying to do is give more details for chemicals. And we also don't cover any other industries.
Yeah. So there's a lot of questions. Can I have one more question now, or do you need to continue?
No, it's my last, almost last slide.
Okay. Ricardo Novelli is asking the typical LCA question: which allocation methods are you using? Is system expense applied, and if so, is it communicated in the documentation?
Yeah. Let me give the typical LCA answer to this. We use allocation according to the ISO standard 14040 series, and then you will know that, well, there's some room for LCA practitioners. First of all, it's documented in the data set, but in short, in the chemical industry, it happens quite a lot that you co-produce hydrocarbons. And these hydrocarbons will be burned to generate steam, which goes into the steam grid of the same integrated production site. So this is the first thing. For this, we use system expansion via the avoided burden. It basically goes into the steam production. And then we go down the allocation hierarchy, so physical relationship and other relationships or other criteria. Basically mass and energy mainly, but this is then documented in the data sets.
Okay.
What we have to say is we have a hierarchy when we use what. So sometimes you can't use, let's say, energy allocation because there is no energy, but we don't do it just thinking for every single data set. We check it for every single data set, but we apply a hierarchy whenever possible.
Okay, thank you.
Okay, thank you. Are there any more questions so far?
Oh yes, a lot. I can continue, but it's fine with your presentation.
Okay, continue first. Perfect. Then we go to basically the last question. How do we package the data? How can you get the data? And we've been working with SimaPro for quite a while. And first of all, we've defined data packages, which Michiel and his colleague got into SimaPro, that those are available directly from pre-consulting, pre-sustainability. And those are 3 data sets. So we have a basic data set, 78 most commonly used chemicals, production consumption mixes, and the main chemical production regions plus a global average. If you need more detail, we have the technology insights one, where you also get the major production technology, and the more comprehensive one is the global insights, where you have the production technology plus all regions available, so more than 190 regions. But of course, this is basically the starter tech, and there will be also others following. The database is much bigger. There are about thousands of products, and if anything is missing, you can search these chemicals on our website, and you can get them on demand.
Yeah. You made a strong plea for regionalized analysis. So what do you recommend for a average user to order?
Yeah. I think it depends on where you produce. So let's say if you're a mid-size company producing in Europe, then the basic chemical package might cover what you need. But if you're a multinational chemical company, or if you're located in one of the countries that are not covered by the basic package, I would recommend the global insights package.
No. Okay.
And maybe one last thing, even with the 1,000 chemicals, it happens sometimes and again, or let's say often, maybe even, that still something is missing. Just write to us. So what we do a lot is modeling additional chemicals on demand. So we're constantly expanding the database. And if you give us a hint what direction is interesting, we're happy to do this and deliver this on demand.
Yeah. So some people are asking, what are the 78 products, and how much overlap is there with, for example, EcoInvent?
Yeah. So of course there is some overlap, because I think both databases started by aiming for the most important one. Just have a look at the either SimaPro Carbon Mines website or our Carbon Mines website. There you find the full list of products and can scroll through them, see all the regions, see the technologies that are covered there.
No. And somebody else is asking about the granularity. How much insight can you see? Is there any data confidentiality and that sort of things?
Yeah. This was, of course, a tough choice that we had go through. I mean, coming from university, we would have loved to give out all the unit processes, but we had the problem, like for the very good data sources, it's just not possible to show them. So due to the confidentiality reasons, we had to aggregate the data sets to cradle to gate data sets. And in terms of granularity, I think the granularity that we have in this database data sets would be like the highest granularity technology by country. If you're aiming for something more specific, so for example, individual suppliers, this is something you can contact on. It's not in the databases, but this is something we do at Carbon Mines.
Are there any restrictions on the use of the data?
restrictions on the use of the data. So of course there's an end user license agreement, which basically says you can't just publish all the data sets, but in very short, but please read the text if you're in the real agreement, is you can do with it internally, the user who got the named user license, whatever you like. You can also publish the results as long as you can't just calculate back our database. So.
No. Yeah, there's a number of very detailed questions like are PFAS chemicals included, or are bio-based routes covered, that sort of things. Perhaps you can tell a little bit if you cover biomaterials, bio-based chemicals.
Yeah, we're currently extending a lot toward renewables. At the moment, it's more limited, I would say, but we're working on this, and this is something we can also do on demand. Of course, always depending a bit on the chemical. If you go to our Carbon Mines website, under data, you will find data search, and there you can filter, browse, and check all the data sets that are in there. And you can also check it every month. So once a month, we expand the data base, and you will find new chemicals.
No. Okay. One question about updating. You mentioned that you will update the data every year. Is that automatically sent to the users that purchased the database before? How does that work?
Yeah, Michiel, maybe this is something you can also talk about, because.
No, that's fine. No, I think in essence, I will explain later, but I think we have two types of licenses, which is an annual license and a perpetual license. And I think if you have a perpetual license and keep your SimaPro service contract, you will get those updates. If you have a yearly license and you start to, you cancel it, then obviously it's like a subscription to a newspaper. You will not get any new newspapers or updates anymore. Some more questions. Well, one question is, can you easily swap technologies for another one? But since you said there are system processes or aggregated processes, it's hard to make any changes internally, I guess.
Yeah. So it depends. If you go for your foreground system, those are the processes that you input yourself. In the background system, you have these system processes which you could exchange. But of course, in an aggregated process, you cannot just change tier 3 or something. So you would go and take the database and take the tier 3 background process. But in this case, you would have to model tier 2 and tier 1 yourself in your foreground system.
Yeah, there's quite a number of questions, so I have to pick a question. How about new technologies? Well, at pilot level, well, I guess you don't have the information for that yet. So
yeah. This is something, a question we sometimes get on demand. So of course, there's no answer for all the different technologies. There could be a wide diversity. So if you're interested, just get in touch.
No. And another question is the scope of the data. It's mostly production, but do you also plan to include conversion or end of life processes? I mean, recycling of plastics or incineration of plastics.
Yeah. So what we're working on is renewables, basically, which could would be the result of the recycling. At the moment, how we see the data is that we provide cradle to gate data sets so that you can use it for your own studies. And in this case, we typically won't know the use case or the end of life. And so we would like to provide the input mainly upstream. This could also go into scope 3 reporting, category 1, purchased goods and services, for example.
Another question, do you include data from the composites industry, like epoxy resins or fiber reinforced polymers?
Yeah. So we have a lot of data of the material. So when you have a composite, let's fiber reinforced polymer, then you might have a glass fiber, for example, and a matrix material. So it could be, I don't know, PMMA or something like this. In this case, you will hopefully find your materials in our database, but we at the moment don't have the finished products.
Okay. Let's see. Yeah, have you ever compared your own data with data in Gabi? That's of course a tricky question. Somebody's asking.
Yeah, I mean, if you build a database, of course you look around, and it's the same like to the question if we compare to plastic Europes, for example. So when we see a difference or someone points us at a difference, of course we explore where it comes from until we are confident that our data is correct.
Yeah.
And of course, depending on the transparency of other data sets, it's possible, or sometimes you can't also not look in there. Yeah.
Okay. Let's see. I think I'm gonna take over from now.
Okay, great.
Sharing. And yeah, I see there are a lot of questions coming in still, and they're not always, well, we're not able to answer all of them. When the meeting is over, we'll go through the question and try to answer them as much as possible. Let's see. I need to get back my screen. Yes. Can you see my screen now?
Sorry, I was muted. Yes, we can see it.
Perfect. So a little bit more about how to get additional data in SimaPro, and one of them, of course, being the Carbon Mines database. In the SimaPro, we have a number of additional data libraries available. Of course, we have the default libraries like EcoInvent, which are installed with SimaPro. Apart from that, we have quite some other databases which are not always or not in the default professional database, and that's for a number of reasons. Some of them, like the Carbon Mines database, are licensed, so you need to purchase them additionally. Sometimes the data is not relevant for all the users because it's very specific or very regionalized. Sometimes it's really specialized, like ExioBase, and it's very big to calculate, so it would add a lot of data loads to calculations. And sometimes, like the European EF database, they have different the special terms and conditions, but also use different nomenclature, which would mess up yeah, the database if you combine them. So that's about the SimaPro databases. If you want to purchase the chemicals database after the introduction from Arne, you can go to our website. You can request a quote and then submit a form, and we will contact you with a price. The price is dependent on the type of license. So we have a distinction between the commercial and educational licenses. Essentially, for commercial use, a yearly price of €1,000 for the basic package and 5,000 for the Global Insight, which is the most expanded one. And of course, the educational versions get a discount. These are the prices, and that's for the 78 processes. And again, these are per named user. And yeah, Carbon Mines yeah, can't tell more about what it is, but that's something to discuss later. Once you have purchased the database, we will send you a download link with a zip file. You run the setup, and then you install your database. You import the installed database into your own database, like you do with the equivalent. Once the import is done, you will see the carbon mines data in your own professional database, and you can use it as normal database. So this is an example how it would look like in your open project window. So we have 3 different libraries. Of course, this is an example. To be honest, we're finalizing the conversion, so it's not ready from tomorrow, but very soon there will be a version. I want to show you a little bit how it looks in SimaPro. I did a few calculations. In SimaPro, I have created a example project. In that project, I already made a few calculations. I have 3 different libraries: basic, global, and technology, and they are categorized in consumption mixes, production mixes, technology mixes. So there's quite a number of processes here. So here you can see the technology mixes, specific technologies. This is for methanol, and I thought because Arne was explaining about the methanol differences, perhaps I can do a comparison between Chinese, German, European, global, and let's pick another random country like the US and do a analysis recipe. But since Arne was talking about carbon footprints, take the IPCC, and you can indeed see the differences between the different countries. So the China one, the first one, is the highest. The lowest is the European average mix, and then we have another European technology mix, and then the German one. No, the blue one is from the United States, and the green one is from Germany. So indeed, you can see there's substantial differences between the different regions, and indeed, it's about factor 4, even 5. So that's quite nice to see. I have to hurry a little bit because it's time. As I said, or as Arne said, the data are coming as aggregated process. So it means a very long list of inputs and outputs. So there's a lot of information involved. We are working on the documentation. There's a little bit of documentation inside the process, but there's also a lot of data available in this methodology manual that Arne mentioned. I can go into detail, but I think we're running out of time. Let's continue with a last poll. And the last poll is about what kind of LCI data would be relevant for you to get. And that's not so much for us. Lost my poll. Can bear with us a few more minutes. Question is really for our database team, what are you looking for? Is it region-specific data, sector-specific data, input-output data, or something totally else, which we have not thought of? Almost half of you has voted now. So. A few more seconds before we close the poll. 75% has, 73% has voted. So last call, and then it's over. 1, 2, 3, and we close the poll. And let's share the results. And it's 42% wants sector-specific data, 41% region-specific data, 13% wants input-output data, 5% of you wants something else. And that always makes me curious what that is. As I said, we were not able to answer all the questions. I want to thank you for your questions. I want to thank you for your attention. I want to thank Arne and Ro for the presentation. And I think you did a really great job. And I hope, many people can use your data in their own work. I find it pretty impressive what you did as a chemist, but also as an SLA specialist. No, I don't know if you want to say a few words, but otherwise we close the webinar.
Yeah, also just would like to say a big thank you to everyone who joined. If we haven't answered your questions yet, get in touch. We are happy to talk to you. You know where to find us on our website, carbonminds.com.
Indeed. Yeah. Okay. Then I wish you all a pleasant day wherever you are, morning, night, evening, afternoon. And perhaps we talk to each other or mail each other or phone with each other another day. And talk to you soon, I hope. Goodbye.